Welcome back to the deep dive. We're really glad you could join us. Have you ever interacted with AI, maybe asked your smart speaker something or seen a recommendation online? And the answer you get back is just, well, a bit weird, or it feels like it totally missed what you were trying to say.
Oh, absolutely. It happens all the time, doesn't it?
Yeah,
And our first thought is often, the AI just isn't quite there yet, or maybe that algorithm needs tweaking.
exactly. But what if?
Mm.
What if the algorithm isn't the main issue? What if it's something, well, more fundamental, maybe even a bit messier? Today, we're going deep into something that's often behind the scenes but is absolutely critical. The role data plays in, well, everything these intelligent systems do. It's not just having data. It's about what data, where it's from, and frankly, how incredibly tough it is to get it right.
Yeah, think of this as looking at the actual foundation AI is built on. It's crucial. And maybe, just as we start, take a sec to think about how much data you interact with or even generate just in a single day. Your phone, websites you visit, things you search for, maybe even location pings from apps.
Oh, definite.
It's just constantly flowing.
It really is. And that brings us to the first point from the material we're exploring today, just how much data is literally everywhere now. That term, big data revolution, it's not just some marketing buzzword. It's like the air we breathe digitally.
It's truly astonishing. Some estimates put it at, what, 2.5 quintillion bytes of data created every single day?
Quintillion, that's, wait, 18 zeros, right?
18 zeros. It's a number that's almost impossible to really wrap your head around.
Wow. And what's really interesting is that so much of this isn't neat, tidy, structured data like in a spreadsheet. A huge amount is unstructured. Think video, audio, pictures, random text. And this is important. It's tied directly to what we do. Human stuff, feelings, experiences, how we connect.
And that's exactly where it gets so interesting for AI.
Yeah.
Because this allows these systems to learn not just about, say, physics, but about how the human world works. You look at data from social media or what people search for. It shows patterns in relationships, interests, what people care about. There are insights suggesting that, how people interact on Facebook, for example, holds a ton of relationship data if you can figure out how to extract it.
Even just talking to our phones, right?
Yeah.
Saying, okay, Google, or asking Siri a question. That voice data, those queries, they're all feeding systems trying to understand how we actually talk and what we mean.
Absolutely. And then you layer on this explosion of connected devices, wearables, tracking fitness, smart thermostats, sensors in factories. Data points are just streaming in from everywhere, painting this incredibly rich, diverse picture of the world.
So this huge, varied flood of data lets AI go beyond just crunching numbers. It lets it start to learn the real messiness and complexity of our world. We see examples of companies using enormous amounts of public text, website content, books gathered by these automated tools. Spiders, they're often called.
Web crawlers or spiders,
Hmm.
yeah.
Yeah.
Just crawl the web, collecting text to train language algorithms.
Okay, so we've got this absolute ocean of data, billions and billions of bytes.
A sea of data, but just having it isn't enough, right? You need to actually do something with it. And that's where algorithms come in.
Right. Data's the raw ingredient. Algorithms are the chefs, or the tools, maybe. They take the data, sift through it, spot the patterns, and then use those patterns to generate a response or make a decision or take some action.
A really good example is how search engines work. Think about Google's rank brain algorithm. It learns from trillions of searches how to better figure out what you mean, even if your query is kind of vague or uses slang. It's already handling a really significant chunk of searches, showing how these algorithms apply learned patterns to solve real problems.
Huh. So next time you type something a bit weird into Google, and it still gives you something useful, you're probably seeing one of those algorithms that learned from just mountains of previous, maybe equally weird search data.
You likely are. But okay, so you need the data, you need the algorithms. But here's a key point that's really emphasized. Just having a lot of data isn't the same as having good data. It's not enough for AI to be truly successful.
Ah, okay. This is where the challenges really start to bite, isn't it? The material points out that current AI, well, it can't just magically pull insights out of raw, messy data streams. That data needs work. It needs to be cleaned, prepared, understood somehow.
Exactly. It doesn't arrive nicely labeled saying, use me like this. And that brings us to how data is actually collected. Historically, a lot was manual. People writing things down, filling out surveys.
There are clipboards and pens.
Right. But now so much is automated. Apps tracking usage, sensors recording measurements, our online clicks.
And that difference really matters when we talk about getting reliable data, doesn't it? The material highlights how tricky it is for us humans to be consistent.
It sounds almost silly, but think about something super basic, like entering a state abbreviation into a form. You might type can.
Yeah.
Someone else types cans. Another uses KS. Maybe someone from outside the U.S. uses USKS, or even mistakenly types KA.
Oh gosh, yeah, been there.
For a computer system trying to group data by state, those are all different things until someone does the really painstaking work to map them all together. Human input is just naturally full of typos, variations, slang, errors.
That's such a perfect example. Anyone who's tried to merge spreadsheets people filled in manually knows that pain. It's just chaos, which is why automated collection, like from sensors, seems appealing.
Exactly. Sensors measuring, say, weather conditions, temperature, rainfall, cloud cover, or monitoring machines in a factory, they tend to provide much more consistent data streams. There's potential for things like facial recognition in a store, identifying regulars via camera sensors. Sensor data isn't flawless, but it generally avoids that human ambiguity layer.
Okay, so automated collection, especially sensors, can give more consistent data. But even then, the data itself isn't static or perfect. You have to actually care for the data.
Which brings us straight to common issues like missing data.
Ah, the gaps. So how do you usually notice that's happening?
Well, often the first sign is just weird results from your algorithm, answers that make no sense. And why does it happen? All sorts of reasons. Maybe the collection process wasn't consistent. Maybe there was a technical glitch. Maybe simple human error if parts were still manual.
And the kind of missing data matters a lot, right?
Hugely. If you've got random bits missing here and there, like one temperature reading missing from 1,000,
Yeah.
you can often work around it. Maybe fill it in with an average or a median value.
Okay, manageable.
But then there's sequential missing data, where whole chunks are gone. Maybe a sensor failed for a week or data transmission was down.
Right.
That's much, much worse.
Right. Because if you're missing, say, all the sales data for the week before Christmas, you can't just average the weeks before and after. That whole critical period is just gone.
Exactly. You've lost that entire segment of reality from your data set. Any analysis of that period or patterns relying on it becomes impossible or completely skewed.
Makes sense. Okay, what else can go wrong?
Well, another big one is data misalignment.
Is that like when you try to combine data from different places and it just doesn't mesh?
Precisely that.
Hmm.
Imagine trying to merge customer records from two different databases where one uses first name, last name, and the other uses last name, first name. Or sales data from stores where the timestamps on the transactions are slightly off because the clocks weren't synced. Or inventory data where product IDs are formatted differently. Getting these different data sets to actually connect correctly so you can analyze them together, it's a massive integration challenge.
Okay, so let's recap. We've got this huge amount of data, but it can be inconsistent, especially if humans are involved. It can have big, damaging gaps. And even when we have the data, getting it to line up from different sources is really hard. It sounds like wading through a lot of noise.
It absolutely is, which leads directly to the next challenge. Separating the useful data from all that noise. It really reinforces that old saying, garbage in, garbage out.
Garbage in, garbage out. Yeah, feels very relevant here.
It does. And this is where the idea of data fallacies comes in common mistakes in how we think about or handle data that can lead us way off track.
Okay, like what kind of fallacies?
Well, the material highlights two key ones: commission and omission. Commission is when incorrect information is actively added to the data. It could be an accident or sometimes, as the example suggests, intentional. Like someone in an accident report falsely claiming the sun blinded them to maybe avoid fault.
So putting bad info in. Got it.
Exactly. And omission is the opposite problem, leaving critical information out. This creates incomplete data sets, which can be just as misleading. If you're only tracking, say, 5-star customer reviews and ignoring all the 1-star complaints.
You're getting a very skewed picture of customer satisfaction.
Totally skewed. You've omitted crucial negative feedback.
It's like selective hearing, but for data.
That's a good way to put it.
Yeah.
And there's one particularly powerful type of omission discussed, especially with human data: the missing frame of reference.
Frame of reference.
What?
What does that mean here? Context.
It's deeper than just context. It's about the lived experiential understanding that data alone just can't capture, but which is vital for true human comprehension. The analogy used is powerful. Imagine trying to truly convey the experience of being in a life-threatening storm at sea to someone who's never even been on a boat in rough weather.
Okay.
You can give them all the data points: wind speed, wave height, temperature, maybe even video footage or interviews with survivors saying they were terrified. But Can those data points ever fully replicate the feeling of the freezing spray, the sheer terror, the physical exhaustion, the overwhelming scale of it all?
No, probably not. The raw data misses
Yeah.
the visceral reality.
Exactly. That frame of reference, that deep experiential understanding, is something data fundamentally lacks. And if AI learns only from data stripped of that frame of reference, its understanding will always be partial, in a way.
Right. So when you put all these potential issues together, inconsistency, missing chunks, data that doesn't line up, adding wrong stuff, leaving important stuff out, this fundamental lack of lived experience, what happens when you feed data like that into an AI algorithm?
Well, the conclusion is pretty stark. Poorly collected, poorly shaped, incomplete, or biased data, especially if the algorithm isn't specifically designed to handle those flaws.
Hmm.
It just leads to outputs that are nonsensical, misleading, or plain wrong. And those bad outputs can easily lead to bad real-world decisions.
And that's often when we point the finger at the AI itself, right? The AI messed up.
That's exactly right. The AI often gets the blame when the real culprit is the compromised data it was trained on or how that flawed data was used. The material really drives home the point. If we want AI that's genuinely smarter, more reliable, more effective, it absolutely must start with better data.
So it's not just a component. Data quality isn't just one ingredient in the recipe.
It's the foundation. It's the bedrock everything else rests on. You can have the most brilliant algorithm, the fastest computer, but if you feed it flawed data, data full of errors, gaps, biases from these fallacies, your results are going to be flawed, period.
Wow. So building really smart AI isn't just about clever coding or massive processing power. It's this whole intricate process, starting with asking the right questions, then the incredibly hard work of getting the right data, making sure it's clean and consistent, processing it properly, and then applying the right algorithms and hardware to make sense of it. Data quality seems central to literally every step.
It underpins the entire endeavor. You can't escape it.
Okay, that really puts the data in data science into perspective. We've seen it's everywhere, yes, but its quality, its source, how we gather it, how we deal with its inevitable imperfections, that's what truly matters for AI performance.
Yeah, it reminds us that the intelligence we see isn't some kind of magic. It's directly fundamentally linked to the data it learns from and how well we manage that whole process.
It really does shift your thinking, doesn't it? Away from just the brain of the AI towards the diet it's being fed. And I guess considering how much of that data, especially the human-centric stuff, comes directly from us, our clicks, our searches, our photos, our words, does that make us, I don't know, not just users of AI, but also its constant, collective, and maybe pretty flawed teachers?
That is definitely a thought to chew on long after we finish here.
Absolutely. Well, please join us again next time for another deep dive as we keep exploring these fascinating systems. Until then, maybe pay a little more attention to the data trails you leave behind.
And yeah, if you found this interesting, share it with friends or colleagues who might appreciate this perspective.
And of course, please subscribe to the channel AI of Thinks so you don't miss our future deep dives. Thanks for listening, and see you next time.